Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to continue working with triangles and proving congruency. And in today's case, we have a special case here of overlapping triangles. Now, overlapping triangles can be very difficult if you try to prove it from the main figure that was given to you. Some people have the ability to look at the figure and separate them in their mind, but I suggest strongly that you actually separate the figures physically and prove from the individual figures that you have pulled out of the original main figure. So there's not much to learn as far as theorems go in this section. It's just a matter of understanding how to pull out the desired triangles that you want to prove and prove them from there. So let's just start with example number one. In example one, we have here that segment DB is congruent to AC, and that segment AD is congruent to BC, and we want to prove that angle D is congruent to angle C. Now, from the figure that was given, when you have DB is congruent to AC, you can go ahead and mark it like this, but that can be very confusing. Does that mean that DE is congruent to CE? Well, it could be from the way it's marked. Or does it mean that DB is congruent to CA? Well, that's what it really should be, but again, it could be confusing. So what I like to do, like I stated at the beginning of the lesson, is to separate the triangles that you want to work with to prove what you have to prove. So in this particular case, if you think about it, you're working with DB, you're also working with AC, then you're working with AD, and with BC, and then you want to prove that angle D is congruent to angle C. Well, if you just go ahead and fill in the rest of the gaps here, we're working with triangle BAD, that's the triangle in red, and we're also working with triangle ACB, which is a triangle in green. Now that's pretty cool. We can see the differences there, but it's even better if we just go ahead and pull those out. So what do I mean by that? Let's go ahead and pull out triangle BAD. It's pretty much a mirror image of what was in the original figure. And also, let's pull out triangle ABC, or ACB, rather. Okay? And if you notice, they're exactly the same way that they were drawn in the original figure. Don't flip them around. Okay? So for example, don't take this and flip it so that it's like this. ABC. It's going to mess you up. Draw it exactly identical to what was given in the original drawing. Okay? You're going to see how this makes it a lot easier. So now that we've separated these two triangles, let's go ahead and prove this. We have DB is congruent to AC, and of course, that is a given. So let's mark it. You know what I think about labeling, since I think it's extremely important. Next, we have AD is congruent to BC, which is also given. Let's go ahead and label that. AD is congruent to BC. Now, from here, what can you tell? Well, if you look at the main figure up here, this segment right here, AB, and you look at the original figures, don't I have an AB here and also an AB there? Okay? There, that AB is attached to both triangle BDA and triangle ACB. So I can now clearly state that AB is congruent to AB because of Hopefully you got it already, the reflexive property. Now, look at what we just created here. We have two very easy triangles that are easily proven that they're congruent. Triangle ADB is congruent to triangle BCA. Okay? Why? Side, side, side. Hopefully that makes sense to you. Now, you may be thinking, wait a second, Mr. Morrow, you went ahead and labeled the triangles incorrectly. No, I did not. If you think about it, this A corresponds to this B, which it does. Okay? The D corresponds to the C, which it does. And this B corresponds to this A, which it does. So be careful how you label those triangles. And now, to prove that angle D is congruent to angle C, very simple, CP/CTC. Congruent parts, corresponding parts of congruent triangles are congruent. So as you can see, separating it makes it a lot easier. Let's continue. Example 2. Again, we've got quite a few triangles here actually, if you think about it. And we have that AC is congruent to AB. Again, we get into a little bit of a problem. When you label AC to AB, are you really talking about AC and AB, or are you talking about AD and AE? It's kind of hard by just placing one tick mark there. Then we have AE is congruent to AD. So how would you do that one? Would you do 2 here? Now you're really confused. So instead of getting all confused and frustrated, let's go ahead again and simply pull out the triangles that we're working with. And in this particular case, we're working with AEC. Why? Because we have an AC to an AB. Then we have an AE, which is this guy, to an AD. Then we want to prove that CE is congruent to BD. So if you think about this, we're working with this triangle right here and this triangle right here. So we're working with triangle CEA, which I just pulled out, and we're also working with triangle ADB, okay? This would be my ACE here, would be the triangle highlighted in red above, and my ADB would be this guy highlighted in blue, okay? So hopefully that makes sense. Pulling them out correctly is the most important part of this. Now it's easy from here. We start with our givens, as always. AC is congruent to AB because that is given. So let's mark it. Then I have that AE is congruent to AD, which again is given. Okay. Now, if you think about this, look at the main triangle and look at your individual triangles. Is angle A shared for both the red triangle AEC and the blue triangle ADB? Absolutely it is. So A would be congruent to itself because of the reflexive property. So now I have my setup to prove that these two triangles are congruent. So I have a triangle ADB, which is the blue one, is congruent to triangle AEC, which is the red one, because of side angle side. And now that I know that those two triangles are congruent, I can easily prove what I'm trying to prove, which is that CE is congruent to BD, which is right here, because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so again, an extremely difficult problem was made very easy simply by pulling out the individual triangles that you have to work with in order to prove what you need to prove. Hopefully that made sense to you. So last but not least, okay, give me a second here. Okay, sorry about that. I had to hide the reasons. Sorry, that was my bad. Okay, now in this case we have a trapezoid with several triangles within the trapezoid. So let's see what we would do here. We start with FH is congruent to MJ. Again, we have a bit of a problem here. When we go ahead and label FH to MJ, what am I talking about? Am I talking about FH being congruent to MJ or FG being congruent to MK? It's kind of difficult to see that. Then we have that G is the midpoint of FH. Okay, that makes things a little bit easier. Okay, if G is the midpoint of FH, now I know that this guy is congruent to this guy, and K is the midpoint of MJ. Well, we know that this guy is congruent to this guy, right? And then they're talking about angle GHJ, which is right here, being congruent to KJH, right here. And they want to prove that GJ is congruent to HK. Okay, that could get a little bit difficult. In this case, it's actually a little bit easier than the two that we saw beforehand because of the midpoint there. But I still would like to show you how to extrapolate the two triangles that we really want to work with because it will make things easier. Okay, in this particular case, though, we're going to use both figures. And let me show you how. Okay. First of all, FH is congruent to MJ. So I'm going to go ahead and label that FH is congruent to MJ. And I'm going to go ahead and label that as my first statement, and my reason is given. Then, G is the midpoint of FH, and K is the midpoint of MJ. Okay, I can go ahead and put both of those statements, and the reason for those are given as well. The reason I'm still working with the main figure here is because I need the main figure to be able to separate the triangles that I really need to work with to prove that GH is congruent to HK. So in this case, I know that G is the midpoint of FH, making this guy congruent to this guy, and K is the midpoint of MJ, making this guy congruent to this guy. Now the reason why I put two tick marks on everything is because we had stated that FH is congruent to MJ, right? So all of those parts are congruent because of the division property. So I know that GH, which I'll mark in green here, is congruent to KJ because halves of congruent segments are congruent, or in other words, the division property. Now we get a little bit sticky, okay? Now we're talking about angle GHJ is congruent to KJH. So we're saying that this angle is congruent to this angle. Now we're getting into the overlapping triangles, and now in this particular moment, I would separate them. You can see clearly that we're working with triangle GHJ here in green, which I can pull out. And we're working with triangle HJK, which I'm going to highlight in blue here, which we can also pull out. So we have our green GHJ, and we have our blue KJH. We already know that GH is congruent to JK. We proved that because of the division property. We know that angle GHJ is congruent to angle KJH because it was a given. Okay? And now we want to try to prove that GJ is congruent to HK. Well, look at the main figure above here. Okay? Look at this HJ. That had a blue and a green overlap on it. And if you look at the individual separated triangles, HJ and HJ are both the same segment. They're both the same segment for both of these triangles that we separated. So we can clearly state now that I'm sorry, I skipped a step here. So this is wrong. This is going to become 7, and this will become 8. 6 will have to be, my bad, I really am sorry. Step 7 here is that HJ is congruent to HJ. This is 7, and this will be 8, because of the reflexive property. And again, I apologize about that. Okay? So now we know that HJ is congruent to HJ because of the reflexive property. And now we can go to step 7, which is that triangle GHJ is congruent to triangle KJH because of side angle side. And now that we know that they're congruent, we can easily state that GJ is congruent to HK because of CP/CTC. Corresponding parts of congruent triangles are congruent. And once again, I do apologize about step 6. Without that, you cannot prove anything else here. Okay? Well, hopefully this made sense to you. Hopefully you learned a lot. Thank you very much. Have a wonderful day, and I'll talk to you soon. Bye-bye.